Today's Daily Dose of Math is, what is a trapezoid anyway? Here we're covering just some of the basic concepts about trapezoids. I have 4 orange trapezoids here. All of them have some things in common, but all of them are different from each other. The things they have in common include that in all 4, side AB is parallel to side CD. You can't see that just from the drawing, so I have to provide the information on the side. And side BC is not parallel to side AD. The reason I point this out is because the definition that I'm using for a trapezoid is a quadrilateral with a pair of opposite sides that are parallel and in which the remaining pair of opposite sides are not parallel. This is the exclusive definition of a trapezoid because it excludes parallelograms, rhombuses, squares, and rectangles from being trapezoids. But more about the different definitions of trapezoids in a different video. This is the definition we're using. I have names for these 4 trapezoids. The one on the left is acute, because the 2 angles at either end of the long base are acute. The second one is called obtuse, because one of the angles at either end of the long base is an obtuse angle. The third one is isosceles because it has 2 opposite sides that are equal in length. It has 2 pairs of congruent angles as well. And finally on the right we have the right trapezoid, not because it's on the right, but because it has right angles inside it. It always has 2 adjacent right angles inside it. Another thing that these have in common is that we always refer to one of the sides as the long base, and we designate that with uppercase B. All 4 of these trapezoids have a long base. This time I have placed them so that all of their long bases are on the bottom. All of them also have a short base, which is shown with a lowercase b. And this is always going to be opposite from the long base. All of them also have a height. I'll start with the right trapezoid. Its height is this upright side. To be a height, it has to be perpendicular to the base. And a right trapezoid has a side that is perpendicular to the base. The other 3 also have heights, but they are not a side of the trapezoid. For instance, I can show the height for this isosceles trapezoid like this. We can show a height for this obtuse trapezoid, and we can really place the height anywhere we want within the trapezoid. And the acute trapezoid, of course, also has a height. All of these heights are perpendicular to the base. The reason I mention the long base, the short base, and the height is because these are used in the area formula for a trapezoid. So you need to know these measures if you want to find the area. Today we're looking at the definition of a trapezoid and whether that definition is exclusive or inclusive. So what this means is there is more than one definition for a trapezoid, which can be inconvenient. The definition that I'm used to using within the curriculum where I teach is down here at the bottom. Trapezoid is a quadrilateral with a pair of opposite sides that are parallel and in which the remaining pair of opposite sides are not parallel. Now that's a little bit long-winded, but I use that on purpose because it's more useful for my students in terms of what they have to know how to do. I want them to be able to focus on the pair of opposite sides separately from focusing on the other pair. A shorter way of saying the same thing, though, is a trapezoid is a quadrilateral with only one pair of parallel sides. It really does say the same thing. All of these trapezoids are following this rule. Of course, we don't know that for sure until we look at this little bit of extra information that shows us that in all 3, side AB is parallel to side CD, and side BC is not parallel to side AD. This has to be there because otherwise the diagrams don't show you for sure which sides might be parallel and which might not. But all three of these have only one pair of parallel sides, so they are trapezoids by the exclusive definition. Exclusive means that certain shapes are being excluded by the definition. We also have the inclusive definition, which looks quite similar. A trapezoid is a quadrilateral with at least one pair of parallel sides. So there's quite a difference between having at least one pair, which means you may have two pairs, or only one pair. Let's look at the inclusive definition now. This diagram is no longer useful. I'm going to use this diagram instead. The top part of the diagram is the same, of course, but what we see here is I'm also including a rhombus, a square, a parallelogram, and a rectangle, because all four of these other shapes also have at least one pair of parallel sides. So by the inclusive definition of a trapezoid, all of these shapes are trapezoids. By the exclusive definition, only the three orange trapezoids follow the rules, and therefore the rhombus, the square, the parallelogram, and the rectangle are not trapezoids. So it really depends on where you're learning this material. In areas where the curriculum uses the exclusive definition, like where I work, the orange ones are the only trapezoids that are following the rule. In other areas where they prefer the inclusive definition, all five of these types of shape follow the rule. The trapezoid, the various types of trapezoids, and the rhombus, the square, the rectangle, the parallelogram. So this is the difference between exclusive or inclusive in terms of the definition of a trapezoid. That is today's Daily Dose of Math. Please like, subscribe, and share.